part two of the presentation, we're going to go through the different stages of the current mosquito project. And first of all, we're going to start with Tim and Mike Beal. And just a suggestion, I've had a couple of people come up to me that are having trouble hearing, and it's because we're turning our heads on the mics. So if we could concentrate on that, and it's exactly what I'm doing here, turning. Okay, so I'll turn it over to you.
Okay, that line is for the front spar. Had an older gentleman, name was Dave Eady. That's Dave there, long hair, past, brilliant mind. He had worked at Massey Harris during World War II. He was on time study. Time study was to see what jobs could be improved, the process improved. Nobody had built a mosquito bomber in Canada. Dave went around, looked at it. For every improvement you made to the production of the wing, you got a $5 bonus. First week he had 25 improvements. They called him into the office. We said, we're not paying you this. You're going to make more money than us. We're going to put you on the design team. That's the kind of brain Dave was. Dave, they were cutting a material called phenolic. Phenolic is very hard. It's a resin board. They took it down to General Electric in Hamilton. They brought a saw blade, said, we want you to weld carbon on these tips to cut the phenolic. GE patented that. Dave came up with the idea. That's the brilliance this man was. He had worked with the United Nations. He had gone to India after the war, and he helped villages get out of poverty, is the best way I could put it. He helped them set up businesses, machine shops, you name it. Dave was quite a brilliant man. Pierre Burton was his buddy at the Kleinberg McMichael Art Gallery. So he had worked on the mosquito wing in World War II. I had been bombarding the de Havilland retirees, wherever I could find anybody that would listen to us, I put a message out. And he saw it through the de Havilland retirees, and he contacted me. And I didn't know what to make of him, but he said, I want to come down and visit you. He said he started his working career on the mosquito wing, and he wanted to finish his career on the mosquito wing. So he put a proposal together. He was going to build a mosquito front spar in his house, in the basement. He wiped out a wall. He incorporated his next door neighbor, who was a designer with Avro on the Avro Arrow. The man eventually went to Boeing in Vancouver, came back to Kleinberg, was Dave's neighbor. Together with about 8 guys, they built the front spar. It took them about 6 months. They were very accurate. Brought it to de Havilland. He called up de Havilland. They were having their 75th anniversary in Toronto and said, I want you to bring the spar to your anniversary. They did on a transport truck. At the end of that, then he told them, I want you to take it down to Windsor. When he was loading up the truck to get it to de Havilland, he called up the OPP and told them, I need 2 police cars to stop on Highway 27. They took out a basement window. 8 guys took the spar out the window, brought it up. The transport truck was parked on Highway 27. The cops had stopped traffic. And that's the kind of guy Dave was. He told the people politely what he wanted done, and they did it. So it went to de Havilland. De Havilland trucked it down to Windsor free of charge. So it sat on a wall back here for a number of years, and then we finished off the rear spar, then started putting the ribs in and off to the races on the wing. So that's a little bit of background on the wing and the spar. Fuselage, got a message from Glenn Powell. I'm not sure how he contacted us, but he knew Tony Yeager. You saw Tony before. Glenn Powell had been working on the molds in New Zealand for over 9 years. He was building the molds again. He had put a proposal to us that we would manufacture 2 drill jigs for him and $35,000 for labor, for wood. He would build our fuselage. And we made an agreement. He came up, Glenn Powell came up here with 2 investors of his and met us and liked what we were doing. And I'm not sure, I'm going to guess the fuselage was done around 1999, 2000. So he did a gorgeous job. And those molds are still being used by AvSpecs in New Zealand to build all the new mosquitoes coming off. It saved us a ton of times. If we had to make those molds, we would have been, oof. Prohibited. Go ahead.
Maybe just to compliment what Tim is saying. Glenn volunteered to make that fuselage available to us. It's a clamshell design. It's two pieces laid up, and then they're joined. I'm not sure, there's an image that really does capture how that fuselage is assembled. I was asked to go down to Auckland to visit with Glenn and do a layout, a dimensional check, if you will. It was a 3-day trip to Auckland and then returned home. I wasn't quite sure what my name was when I got back home, but it was a great trip. The dimensional accuracy in the placement of those ribs is absolutely phenomenal. The image that I projected was, if we're out of tolerance, we'll simply raise the temperature in the room. I'm thinking that wood will expand just the way we need it. It was that close. His work is exceptional. And a gentleman. Tim, did you want to start?
Yeah, you talk about engines.
All right, may I?
I've got to take off back to work, sorry. Okay.
Tim has to leave. He's a working stiff, so he's asked me to take over to tell the engine stories, and I'm delighted to do that. Thanks very much.
Well done, Tim. Well done. Well done.
This is one of my favorite stories. Obviously, the information that you've seen beforehand, our Merlin engines were very much melted and really not usable. And we knew that at some point we're going to need 2 Merlin engines. And the fellow on the left that you see there, the tall fellow, his name is J.P. Brescason. And I have to tell this story, because J.P. was, how to describe it, the most enthusiastic guy that I've ever met about acquisition of mosquito parts. Let me tell you the story. JP was in and around Assiniboia, Saskatchewan, hunting. He was walking through a field with a dog and a shotgun and a few other fellows, and they were shooting pheasant. He was out hunting. And the guy next to him said to JP, "Hey JP, do you see that farm over there? That guy has got aircraft in there and a lot of parts." And the way I like to tell the story with JP's enthusiasm, he almost threw the shotgun down to the ground, walked through the field, over the fence, through the ditch, and went stuck out his hand and introduced himself to a man named Harry Werrett. Harry was everything he was described as, a collector. He had a Hurricane aircraft in there that he was flying, and a couple of other World War II type aircraft. And when JP introduced himself to Harry, he said, Harry said to JP, "So where are you from? What's going on?" So I'm with a group in Windsor, Ontario, called the Mosquito Bomber Group. We're part of the Canadian Historical Aircraft Association. He said, "Oh, I've heard about you guys. What are you up to?" "Well, we're trying desperately to put a Mosquito together, and it's a lot of work, but we're doing it. It's coming along." And Harry looked at him with a very serious face and said, "JP, did you say you were charitable and non-profit?" And JP said, "Yes, sir. We're very charitable and extremely non-profit." Harry said, "Follow me." Because they had a discussion about, what do you need? What are you guys looking for, JP? He said, "Well, one of the things we need is we're desperately looking for a couple of Merlin engines of the era. And you know, every number we hear begins at 100,000. If it's 100,000 pounds, 100,000 US, big money. And yeah, we just don't have that kind of money." And Harry said to JP, "Follow me." And they went into Harry's barn and walked past the Hurricane aircraft. And in that barn was another room. Harry opened the door, and there in that room were 2 Packard Merlin, exactly the Merlin engines that we need for this Mosquito. Harry said, "I tell you what, I'm keeping one of these engines because I'm still flying my Hurricane, and I may need an engine swap. So I'll tell you what I'll do. JP, give me 10,000 Canadian, and you can have that engine." I got a phone call. And again, back to JP's enthusiasm. This is the image that I have when I spoke to him on the phone. "Mike, I found this we got the engine." "Okay, Jay, I'm with you. It's the right engine?" "Yeah, it's the right engine. He wants 10,000. "Wow, okay, leave it with me." And I called, this is part of, by the way, this is part of that unseen hand that we talked about. Finding these engines in that barn is part of that process. It's absolutely extraordinary. So I called a fellow that had been hanging around the Canadian Historical, and most delightful. This is one of the great individuals. His name is Glenn Mitchell. I just received permission from Glenn to be able to tell this story with his name, so bear with me. So I called Glenn and I said, Glenn, I'm looking for 10,000 Canadian, and I need it really quick because these engines are available, and JP Brescason's about to have a heart attack out there. I've got to get these engines, get the money out to him. He said, Mike, stand by. Issued a check for $10,000, moved it off, got the money, we fired it off to Harry Warrett. About 3 days later, I called Harry, and I said, Harry, everything okay? Did you get the money transferred? The money's no problem whatsoever? No problem at all, Mike, that's good. You guys are really serious about this, aren't you? I said, yeah, Harry, we really are. If you change your mind and you want to sell that other engine, please keep us in mind. Tell you what, give me another 10,000, you can have this one. Harry, I'll call you right back. Hello, Glenn. Hello, Glenn. And Glenn said, yeah, I got you covered, don't worry about it. And we fired the money off to Harry, and he was delighted, pleased for us. And again, that unseen hand, someone is watching out for us. Now it gets better. I've got engines out in Assiniboia, Saskatchewan. How am I going to get them home? Hello, Randy Sear. Hi, it's Mike Beal calling. By any chance, could you maybe arrange to have a truck pick up 2 engines in Assiniboia, Saskatchewan, and have those delivered to... And by the way, you know I have no money. I got you covered, Mike, no problem. Randy just keeps delivering. Or Richard...
I used to be able to jump down. Hi, my name is Richard Fox. I manage the Mosquito project. I've been doing it about 13 years, and it's just been a pleasure. So I'm just going to go through some of the stuff that we do on the plane. Number one, we could have never made the plane without the prints that we have. Tim Gillies, this is the first time I've heard this, has managed to get a lot of the prints. But the prints that we have now, I think we're on our 3rd set, Michael, right? Yeah. We purchased from the Smithsonian. The Smithsonian have a set of de Havilland blueprints for the Mosquito, only because the Americans bought some of the planes and took them home, so they needed the prints to do their own repairs. So this is not one of the prints, but this is a drawing. We use all kinds of books and manuals, and we have a whole corner of the shop that's all devoted to paperwork and research and that. This here is actually an original print. I don't know if I can get too close to that speaker. And what you're seeing here is actually just a piece of wood. If you look carefully, you'll see all the different grains in the wood are running different directions. That's because we take a timber and we actually slice it up, and then we run it through a planer to get the dimension that's called for on the print. And then all these grains are all basically mixed up. So we have grains going in different directions. They're all glued with special glue we use. It's an epoxy. It's called the West System. And it makes for a lot stronger material. Here again is another print. This is a print of a rib. This is the rib that would be used in the front spar. It's in 2 pieces, the front part of the rib, and then the rib that goes between the spars. And it gives you information on the rib. We have about 8,000 drawings and, we have about 8,000 prints and countless drawings and photographs and videos, and it takes a lot to find out stuff. This is a picture from one of the manuals. It's basically just a layout picture. It tells you where things go. So the one on the right is a radiator compartment. They're on the plane now. They go between the fuselage and the engine. everything you see here was made here in this particular drawing. The heavy ribs are 100,000 aircraft grade 2024. I actually had to bring that in from Oklahoma. That's the closest I could find it. And this is a material specification that we use. So I'm just going to go through our adhesive we use for fastening the wood is the Stewart system. We use that since we started. It's a 2 and 3 part system depending on what you're doing. There are also some fillers that go with that, and it's an epoxy. Fasteners we use are all aircraft grade. We use nothing else. They're all AN nuts and bolts. And the wood type. So some of the fellows up there have mentioned some of the wood already. The main structure of the plane, the spars, the ribs, and different things where strength is important is Canadian Douglas fir. We also use Sitka spruce in a few areas. Some balsa wood is mostly in the fuselage where it's encapsulated. It's and gives tremendous strength without adding a lot of weight. Moisture content, of course, we look a little bit for that. We don't want anything dried out. The ring growth. So when you look at a piece of wood, we look at the number of lines, the ring growth, how many growths has that piece of wood had. And we need 10 growths per inch, and it has to be uniform. We don't want to use a tree that's been stressed out or anything like that. So that's all important. And then grain direction, that's on the print. After the break, if you want to come down and look at the plane, a few people will be there. Some of my crew will show you how the grain runs on that. And that's purposely done by de Havilland when they built the plane. You'll see some's running on a 45 and some is horizontal, then turns to a 45, especially at the tail. They did that to compensate for the twist of the 2 engines that turn the same way. And we built to airworthy standards. So we had a question here about whether the plane will fly or not. For the last 12 years and probably even more, we've been working with retired, well, at one point he was still active, but he's since retired, but that doesn't make any difference. And he's a transport inspector for aircraft. He's actually written books on wooden airplanes of this size. So we do that, and we continue to do that and see where that goes to. So the main wing, that's the first thing that I was involved in. When I got here, the fuselage was in the original shipping crate against the wall, and the main wing was on its nose. And I worked under Meyer Fields, or my mentor, and a few of the years into it, he said, "You'll probably be doing this." And here I am. So the main wing nose fabrication, that big pile of, it's wood is what it is. It's plywood, just regular, good good 2 sides plywood. And we take the print, we make it full size, and we glue it on the wood, and then we cut that out. And the piece below, you can see the skeleton. So that's the true rib that we make. So it's all made in pieces. When we cut the wood, we cut to 3 decimal points, and we try to stay within 2/1000ths of an inch. A piece of paper is 3/1000ths. That's how tight we cut. If it isn't right, it won't fly. And this is about where I came in this area here. The main wing is on a jig, and you can see the ribs going from the upper spar to the spar on the bottom. This is later on we turned the wing, we rolled it over, and these are the stringers that run. So it's a complex piece. You have an outer perimeter of the front and rear spar. They're connected with ribs that go from one side to the other. Then there's a piece of plywood, again it's all aircraft grade, that this is all glued and screwed on top of that. And now we start with the stringers that run all the way from one end to the other. The wing is 54 feet long. All those pieces are all scarfed together on a 15 to 1 ratio, 15 degrees. That's what gives the wing the tremendous strength that it has. So basically you have 3 skins in the wing. This plane, fully loaded, weighs around 25,000 pounds, and the plane has a top speed of well over 400 miles an hour. So you need something really strong. Here's the leading edge. You remember those pieces that we made, and they're being fitted there. Everyone's a different size, and again, they're all within 0.02 of an inch. Another shot with the leading edge going on, and then you can see that the skin that covers those is lying on top of the wing, and there is a piece of upper skin that's there too. We needed a way to put the skin on to the leading edge, and we came up with this Venetian blind idea, where we had a bunch of scrap wood and we made long pieces and put on ratchet straps and glued it and put it on. That was a fun thing to do. There's a good looking guy at the top there, and this is the center part of the main wing. You can see how complicated it gets with the stringers and that, and there's a lot of blocking in there. Those holes that you're seeing, and there's like a dog bone at the top, a hole there. These are all pass-through ports for the fuel. There's 10 fuel tanks in the wing, 5 on each side, and all that fuel goes back and forth, and that's what the holes are. Some of those holes are for. Pretty much have all the wing skin on now. You can see again those holes that are there. They get covered with panels, little covers later on. You see the number of screws. I'm not sure how many we had in the wing. I'm going to say 3,000, something like that. And everyone goes in by hand. Every hole is drilled, and we use silicone bronze screws that went in there. And then later on, they're covered. I think there's a shot of that next. No, there's not. This is the wingtip, beginning of the wingtip. This is the outer curved part. Very complicated piece to make, although the book that I read said it's easy. So what the problem is here, it's an elliptical shape, and you're picking up a dihedral and a center line on the one side and then joining it to the back. So it basically starts out and it's curving all the time, and it's not a how do I say that? It's a complicated curve. It's not all just one curve. It changes as it goes, and it goes up and down and around. And that was difficult. We made 3 sets of those, probably 2 years of work, and scrapped most of it before we finally came up with the answer. And it was a friend of ours, an engineer, that drew it out on a long piece of paper. And when he did it that way, you could see how it was like a snake. And then once we had that pattern, we were able to make it. The ailerons. So the ailerons were actually made here. I know there was a comment saying the ailerons came from the north, but they didn't. They were all made here, all from scratch. Hundreds and hundreds of parts. This is Ryan, one of our youngest guys. He's an engineer, graduate University of Windsor. And he's standing next to some of the nose ribs. Now, unlike the wing, the aileron is made out of metal. This is the main spar of the aileron. It's 3 pieces. And all those holes you see in there, they're for one reason, just to get rid of weight. That's all it is. And every hole is cut, and then we have to flare that hole to keep it from cracking. We're putting the spars on. The spars are on the white here. And in the background, you see the other one, the other spar. So we're building 2 spars at the same time. We did this through COVID, and COVID just killed us. Just at some points, we were only allowed 5 people in this building. So that really slowed us down. But we probably had at least 2 years building ailerons. We only work 2 days a week as volunteers. I put in a few more hours maybe than the other fellows, but and we work as a team. There's, I think, I don't know who that is, I'm not sure. Anyways, this is the spar. The yellow is primer, the silver are some ribs that are going in, they haven't been primed yet. So it's primers and stiffeners. This is all put together with rivets. We have a lot of different kinds of rivets, and some are bucked and some are pulled. That triangle there is a joiner plate. The spar is in 3 pieces, and each section where it joins has a complicated stiffener and joiner plate. This here is our homemade press that we use to make the curve shape on the leading edge of the aileron. I hope I'm not losing too many people here, but so the ailerons are the flaps that go on the wing, and they go up and down and make the plane bank, if you don't know what I'm talking about, ailerons. So, and there's a leading edge on that, just like on the leading edge of the wing, and there's a curve to that. So we came up with this idea to make the curve. And we're using it here. You see the deflection in the steel tube on the top, how much pressure we're putting on that. And there's the end result. We made that curve, and that's exactly the curve that we need. It's, again, that curve is not something that you just kind of just make a half a circle. It's not like that at all. That curve fits those leading edge ribs. The blue is just a protector paper that the shipper uses, and the real aluminum is nice and shiny. So that's a preliminary fit, and then that gets riveted onto the ribs. Yeah. So we're working there, and those are little sticks that are sticking up there. They're called clecos. We have thousands of them, and with a special pair of pliers, you can squeeze them, and the points kind of release, and then you can put that in a hole, then you let the pliers go, and then it holds it in place. So you assemble it all in clecos before you start fastening it permanently. Here's the aileron on edge now, and you can see that it's coming along pretty good. A lot of clecos in there, and this is built on a bench. That aileron is 13 feet, 6 inches long. And there's, of course, there's one for each side. And here it is with the skin on now. That's Bob Pageau. Bob's one of the members. And he's fitting the aileron to the wing. The flaps. So there's 4 flaps, 2 on each side. This is our St. Thomas location. Guy Moore, who is a member of our team. Guy's a retired mechanical engineer, really smart guy. And he made them at his house. So this is, they're kind of like a wing, maybe a different size, but they have that same profile with that rounded leading edge, and it tapers off to a very sharp edge. And each rib is all made out of wood, so. And there they are there. And that's Marv Field's closest, and I think that's myself. And Ron Rounding, he's our head carpenter. Ron is fantastic with wood. That's the flaps and the skin, excuse me, that's the skin for the leading edge to the left in this particular picture. That finish that you see is actually the West System glue. We take one of the parts of the glue, it's called the special mix, and we thin it down with acetone, and we put that coating on. So that keeps the dirt from penetrating into the wood. This is the flap hardware. So our machine shop is open. It's really kind of messy, but it's open today if you want to go see in there. We have, I believe, 4 machinists. We make a lot of our own stuff out of metal here. And this is the flight actuator bracket. There's one on the table over by the plane. You can have a look at that. Very complicated piece. Originally we had some that were cast, but I'm not a fan of cast, and I actually found out later on that on one of the prints it said that they were forged, which is a different process, and there's nobody that forges pieces like that in Windsor that I know of. So we made them out of solid aluminum billet. They'll be there forever. Here we are, we're just demonstrating how the flap's going to fit. I think that's Guy Moore in the far part of the picture there, and Marv in the center. And yeah. The tail fin or vertical stabilizer, whatever you prefer, the back of the plane, and here we are starting that. So it's kind of like a wing, but it's on its edge, and here is, again, the spar. And there's 2 of them, the rear spar, and there's another spar that kind of goes down the front edge. And then there's also one in the center spar. The hardware is in the green, that's in a prime paint, and those gold things are nuts and bolts that we use. That's all aircraft grade stuff, that's all AN aircraft. And the pieces that are in the green, we made those here. That would be 2024, probably T3 material. And Mr. Pajot standing and fitting the spar in the back. And again, the tail fin on the bench, and we're working on that. And I want to remind you too that all of these dimensions are all within thousandths of an inch that we do. We don't use tape measures too much. Most of the wood's cut and we measure with a vernier gauge. Ron Rounding on the right, and that was Ron Barnard on the left. And looking at that. The hull at the bottom was on loan from a fellow from Tennessee. So we were able to use that to fit the vertical. And here we are again putting it on there. The metal structure that you see a little bit forward there, that's a gantry that I scrounged. No, the metal, yeah, that one. So that was a gantry that I scrounged from somebody on the base here, and I'll show you in a few moments what we did with that. So we're fitting the spar for the vertical stay. One thing I'd like to mention there, that has a 1 degree angle on that, so it's actually leaning back, so it's a negative 1 degree. So it's like you go in a restaurant and you open the door and it swings back and centers. So that's why they have that. Helps the pilot center the rudder. Again, that picture of that. I have about 12 guys that are on our team. Everybody works great and does their thing. And this is the tail fin with the first skin going on there. You see all the ribs all lined up. And there's Ron doing some finishing. And on the right, the fin being fit again. It bolts onto the hull with some pretty robust fittings, as you can imagine. That has to stay on at over 400 miles an hour, and on a dive, these planes would be up more than that. The rudder. So the rudder's kind of unique in the fact that it's metal. And here's a rudder. We had an original rudder, but I think we kept one rib. And the leading edge cover, we kept that. But everything else we did new. And we made those our first attempt using soft aluminum, and then we sent it to St. Catharines to be heat treated to take it up to a T3 condition. The curved edge that you see on the right side, it's on both pieces, but that curved edge, that trailing edge, that's made out of tubing. The one we had was in terrible condition, but we were lucky we had a sample. So if I don't have prints, a sample is the next best thing. And just to give you an idea what things are worth, that edge there is about the size of one of my fingers, and I think it's around 12 feet long. I called a guy in Flint, Michigan, and he said he could make us one for $14,000. So we did it ourselves, and yeah, it worked out good. So we're putting the rudder on with the lift truck. Now, what you see here now is interesting is we've covered that with fabric. We use a Dacron blend fabric, and we have a wonderful young lady somewhere, Mary. She does all the fabric work on all the planes in the hangar here, not just the Mosquito, but the other ones. The gray, covered in the gray now, is the fabric, and that's the last part of the glue, and it kind of comes out in a gray color, so you can see that. A horizontal stabilizer. There's the spar for the horizontal stabilizer. So the horizontal stabilizer, or the tail wing, is much the same as the main wing with a horizontal stabilizer. It's 18 feet 6 inches plus or minus 60 thou. Anybody know how much 60 thou is? Not very much. And these are the ribs. They're different than the front ribs in the fact that they're all made at once, and then you just cut them in half. So it's a time saver for de Havilland. And it's coming together now with the front and rear stabilizers, and then the ribs going through. It's just like a big model airplane, eh? The bracketry, that's all made here, and all the bolts are all AN bolts. Another shot of that. So what you're not seeing here is the number of blueprints it takes to make that piece. You're literally got a whole desk full of these things. And there'd be, on that piece there, I would say there's probably 300 to 500 prints that you need to be looking at. Every little piece of hardware and every little bracket, it's all part of that. And we're fitting the elevator, which are original Mosquito elevators, and we're fitting them to the wing, the tail plane, to see how that fits. And we got a good fit there. And there, again, another shot going on the back of the plane onto number 7 bulkhead. Another shot. This is the tail cone that goes on the back. We didn't have any prints for this, and we didn't have much for this at all. And I called down to New Zealand, and they wanted $21,000. This would be like about 10 years ago for that piece. What we did have was some wreckage, 2 pieces of wreckage from Tennessee, and we calculated what we needed in the middle. I made a fiberglass mold, and we come up with that. That's made out of 30 thou. That's Norwegian birch on that. That's Norwegian birch also. Mike Durand had a lot to do with that. And it's all stripped like a canoe. and you run them this way, and then you run them 90 degrees the other way, and then you run them again, and it's all glued together. Tremendously strong. And that just covers that back end on there and holds the tail light. Another shot of that, and here we are, we're putting the steward system on the wing. You see how it goes around the edges? So it's a fabric, and Mary uses special scissors to put that on. I think there's a shot with the iron. So, with the glue, the glue uses heat to set, and we actually have 2 or more of these irons, and they're on together, so that the temperature, as that iron cools down, you change irons to keep that temperature the same. It goes on at 3 different temperatures. Leading edge. The elevators are what makes the plane go up and down, of course, and these are genuine Mosquito elevators. They don't have too much history on them, and we're fitting them there. We were asked by our inspector to at least take off one side and see what's in, and much to our delight, they were just like brand new. That's Fred Netherton, Dr. Fred Netherton. He's one of our members. We did some repair on it, some dents and things that we took out and changed a few panels. And there we are, there are some panels going in. The aluminum we use is aircraft grade. We use 2024, and it comes in different hardnesses. And we also use the 6061, again, in different hardnesses. And we get that out of Brantford. This is the skin going on for the elevator, the new top skin. You can see all the clecos in there. I don't know what the tape's about. And when they're completed, and so the empennage, I think that's what that's called, vertical and horizontal, and the elevator. That's all been completed now. So here we have, I think, we'll show you how we did this. So that gantry, again, it was in a field. So we dug it out of the field and got it here, and then all the wheels had to be changed, and then we found out it didn't fit. We couldn't get it in the door. So we had to take it apart and get it in the door and put it back together and put it over the plane. And then we did it. You see the circle on the right. So that's a stress point when you're picking up the fuselage. There's only about 15 or 16 inches of wood in that area. And during the war, when they were repairing these airplanes, it was quite common that they would crack there and break. And there's no real repair for that. So the fuselage would have to be scrapped. So we were extra careful. We put that big long steel beam out the front and used that. You can see just a little strap there to hold that on. And then we also had 2x4s holding the center. And you'll see in a minute how that works out. This took quite a while, so we've had to adjust the video so we wouldn't be here for an hour. That's me just bending over there. You can see how hard I work. And we've rolled the wing underneath now. Very cool that's there, and I think that's Tony in the front. It's been a big day for us. You can see how well the wing fits. That curve on the top, you can see that air gap there, that's supposed to be there. And now we put the pin in here. So what's so neat about this is you have a wing that was made from scratch, built in Canada and North America. The fuselage was built in Australia, or I'm sorry, New Zealand. Never talked to man, never seen the man, he never seen me, and the pin go in with a rubber hammer. So that was a pretty good day.
Don't look too far.
Measured that from wingtip to wingtip, and then you go around the other side, and we measure from wingtip to wingtip, and we're within 90 thousandths of an inch. And that changes every day as the humidity changes. The cockpit canopy, this is a real cool thing that we had. The canopy that we had, I believe, came from New Zealand with the fuselage. Tony Yeager set it up. But it needed a lot of repair. And I'm fortunate that we have access to a welding company in town that does superior welding. They actually weld under microscopes. They do surgical instruments. So they repaired all the canopy frame for us. And they donate all their time. I couldn't build this plane without the suppliers that we have that donate their time, material, expertise for us. And that has to do with laboratory analysis on metal and other pieces. People that do laser scanning, that take an object, a laser scans it, and then makes a print so that you can give that to another guy that'll make the part. And in this case, a lot of that was used. So here's the frames ready to go, or pretty much. And is this another video? Oh, yeah. So the canopy didn't fit the fuselages very well, and they did that on all the planes. There's actually a letter from Jeffrey de Havilland, the guy that came up with the idea for the Mosquito and actually manufactured them. And Ron, our super carpenter guy, he had to build up different layers to get that lip that comes up to seal it. What we're doing here, actually, I'm making a commercial for a guy, and he sells abrasives for sanding. So he's donated a couple $1,000s worth of sanding material, and did this commercial. So,
That's oxy.
it's pretty cool. It's on the internet. Sample parts. So these are the windows for the Mosquito.
What about the block?
I'm not sure where these windows came from, but they were all broken in pieces parts. So again, through technology that we have today, we took all the pieces and I put them together with tape, and then took them down to a company down the road here called Inspection Air. And they scanned them with their laser scan and made a print. From the print, I took it to another company, and they made the molds. We bought the acrylic plastic, aircraft grade, came out of South Carolina, and then they pressed the windows in their gigantic pizza oven and made those windows. I said all that in probably 30 seconds. It probably took me 3 years to do that, and a lot of talking. And that, and that was all donated, all of that. Even the nuts and bolts, well, not the bolts, but the nuts, they're special nuts. They look like a nut that you would see on a bicycle, only exaggerated. And a fellow came in here from, actually it was Robin Lee. He owns Lee Valley. You may be familiar with that store in town here. And Robin came in, and he made a fatal mistake and asked me if I needed anything. So he made 250 nuts for us. So that was a big help. That's Pierre there. That's putting the windows together. On the left is John Lesbrance, and he's up on the wing. He's got the safety harness on. The board insists that we stay safe here. And who's looking down? Is that Pierre? I think it's Pierre. That's a shot from, he's up on top of the plane looking down through the escape hatch. But you can see all the windows. So I think we used the two bullet proof windows in the front. I think all the windows actually have been changed. I don't think there's any original windows, is there? I don't think so. No, they've all been redone. And the blister on the front, the nose window, the perplex that's there, that's where the navigator bomber would lie down on his belly, and at the right time he would drop the bombs. It's a good shot of our radiator boxes there, the gray, and in front of the engine. Well, the landing gear. These are pieces that came from the north, the samples. We used those for taking some measurements, and also some of that went to the lab to see what it was made of. The lab gets a kick out of stuff when I bring it over because most of it doesn't even make their chart. Those planes were built out of garbage. The metal they used was terrible. Aluminum in those days was fairly primitive. They called it L-clad and not aluminum. These are brackets. I think the silver one is an original one and the green one we made. On the left, those are all fittings that were made in-house from solid aluminum billet, 6061 T6, which is the standard for something, it's a really tough aluminum, not especially hard, but very tough. And yeah, so that's just a sample of what we did. Bernie Plant on the left is one of our machinists, and on the right is Jeff Shannon. He's no longer with us, but they're making that. These are some brackets that, so they utilized the bracket to hold the wing and engine together. So you have to kind of look closely. On the left is a close-up of that bracket. So it's like 90 degrees and it goes up top. What's interesting about that is all those bolts and nuts that you see there that hold it on, we had the original ones, of course, and from that sample we found out that they were only made out of like a 1018, 1021 material, which is something that you would put your kid's swing set together with. That's what they used in the war. We upgraded. Here's the landing gear, and it's in the collapse position. And you can see how tight the wheel goes up into the wing. And another shot of that. And the plane up on its wheels for the first time. We've done all our own hydraulics here. We've rebuilt all the cylinders. We've used modern urethane seals and cups and washers and everything for the hydraulics. So here's a test that we're doing here. Good looking guy there working that. And you can see with that wheel fully retracted. So we're going through the, it's a lot of years doing this. They gave me 30 minutes, to do 13 years on this plane and countless hours. So is this, is this the end of this?
One more thing at the end.
Oh, one more? Yeah, so here's our Merlin. So these are 225 Packard Merlins that were built in Detroit, Michigan. Packard built 55,000 of these engines in 5 years for the war. There's different kinds of, different models of Packard Merlins. The Lancaster has a different engine than us. They have 224s. These engines here, depending on what book you go into, they're anywhere from around 1,600 to 1,730 horsepower each. The propeller on this engine is, although it's our original Mosquito propeller, it was damaged, and I cut the ends off it to make a test propeller. We made the stand here, and I'll leave you with this final surprise. I want to just thank a few people. I have to. All the members of the Canadian Aviation, they come by regular, give me ideas. Some I use. And that's a big help, a big support that we have here. And if you have a problem, you can always find somebody to help you. I didn't make the plane or build the plane. My team did. I like to do it as a team. We have some fun as well, and if you can't have fun here, why would you want to come? I enjoy working personally, but we do have our famous coffee breaks, and we deal with all the problems of the world. We do that. So, and I need to thank my wife for letting me come here. So, anyways, I'll leave you with this. I'm going to be down at the plane after. I'll be standing next to my donation box. Okay.
We're here.
I know you paid your $10 to get in here, but I only get a little bit of that. I need a lot more. And I'll be glad to answer any of the questions. Also, some of my team is here too, and they'll be around, and they're all well informed about the plane. So, really, thank you for coming. It's been great.
Well done.
Nothing like the sound of a Merlin. How many of us were in Windsor when the Gold Cup races were being held on the river? We knew the minute those races started that there were Merlins down there, and it was the sweetest sound. So, are there any questions for Richard that he can handle here, or he can handle them back at the donation box? Yeah, donation box. Yes. Yes. Are they going to fly this plane, Richard? We're going to pin you down.
Well, it's a little bit premature yet. I don't know how many more years it's going to take to finish the plane, and I'm not getting any younger either. But one thing we have going for us is it is being monitored by a former Transport Canada inspector. There's documentation on the plane. Transport Canada is not interested in the plane right now because we're too far away. It's as simple as that. If we can get close to that point where we think we can fly the plane, then they'll become interested. Our inspector was here just 3 weeks ago. He was here just 3 weeks ago, and we spent a considerable amount of time going through on the internet, Transport Canada's site regarding what can fly. And because this plane is typed, meaning there are other mosquitoes in the world that fly, we have to be, we can't go into that category because this is not a mosquito per se. This is a mosquito replica. I cannot go down to the mosquito store and buy 10 of those and 2 of those and 3 of those and put it on. So with that in mind, Transport Canada in their wisdom have made provisions for planes like that. So we would have to go with what they call a flight permit. So it is possible that the plane could fly if we get that part. The money ahead is big time. In order to fly, you would have to have the engines certified. To get them certified means to be rebuilt. There's one person in North America who does predominantly all mosquito engines, vintage 12, a fellow named Jose. I've talked to him several times. He does the engines for the Lancaster in Hamilton. One engine is roughly about $225,000 now. We got 2 of those to do, so that's, you know, you're talking $500,000. We haven't done a whole lot of hydraulic work other than cylinder work, but all the valving and all the things in that, the electrical, these are all big numbered ticket items. I have one radiator and it leaks. The other one I don't have. I found one in England. He wants roughly $200,000 American. And the numbers just keep on going. I priced out some fuel tanks. We don't need 10, but 10 is what it calls for. A fuel tank is roughly $14,000. And airplanes are super, super expensive. And then to fly it, like I told you, that engine burned 10 gallons of fuel in 14 minutes. And I got 2 of them, and those engines aren't even working. That's just kind of buzzing on a stand, doing nothing. You know, when you harness it to a 13-foot propeller and then make it go, the fuel burn just goes right to the roof. So, and then insurance is just a whole other subject. So, but you never know. I'm not saying I'm not going to do it. And maybe I'm not the guy that's going to do it. Maybe somebody else will fill my shoes one day and say, yeah, let's do it. And I hope that would happen. So I made arrangements. When I get buried, I'm going to have a skylight so I can see it go by. So thank you.
Another question at the back here?
I can't hear him.
How did they keep all the,
Tolerances.
oh, the tolerances?
Yeah, like when they're producing it fast for the war. How did they?
Well, back in the war, in the 40s, they would have had micrometers. We use verniers because they're a little bit easier to work with. But yeah, they had micrometers, and I don't know when they came out, probably turn of the century or so. Yeah. I mean, the micrometer will take you down to 1/1000 of an inch. Yes, sir.
You're talking about the front end here, and you referenced
Is this back during the war? Yes. Were they as tolerant
With the wood?
with the wood as they were with the metal parts?
Yeah, it's all there. It's all documented. Like I said, we have copies of the original print, and it's there. So they would have cut to that tolerance. It tells you right on the print how much, and most of it is plus or minus 2 thou or plus or minus 3 thou. So we even have some prints. You look at them and there'll be it'll say C note. So on the bottom of the print there's a lot of writing, and you go see note number 6 or whatever, and it'll tell you that the information you need for this is hanging on the clipboard on post 41 aisle 7. We haven't found that post yet. So as the plane was built, they were making changes constantly, and a lot of those changes weren't necessarily recorded in the print right away. They just put it on a clipboard and put it up there. So you have to remember, this is wartime, and it was all about getting the plane out there. I believe they were building about 8 of these planes a day. Normal was like a good day, and they were only flown for 6 hours by a test pilot, and then they were shipped overseas. Some went by ships, some were flown over by ferry pilots, which was very dangerous to do. So the pressure was on to get the plane there. I don't think they worried about tolerances all that much, as long as the thing flew. Life expectancy was what, 3 months?
Roughly,
Yeah, on the Mosquito, it was about 3 months on the plane. The plane that this one's named after, KB-161, went overseas in May or March? And it went over in March. It was shot down in May, and one guy got out and the other guy got killed. Yeah. So that's roughly 3 months. The Lancaster, I don't think the Lancaster did as well. 1942, 43, life expectancy, and that was just a matter of weeks. So I appreciate what all those guys did for us. So. And today's D-Day, so think of that. Yes, sir.
Richard, did the German Luftwaffe have planes, any plane that was as fast as a Mosquito?
Was there any plane fast as a Mosquito?
Yeah, until they brought the...
Oh, Germany?
Yeah.
From what I understand, like the Focke 190.
The late version?
The later version. You know, I'm kind of more of a technical guy. You want to build something, or you need an idea, I'm there. Historian, I know basic stuff. Mike knows it better than me. If you want to talk to Mike after. But I know the plane was really fast, but the Germans knew all about it too. And if they couldn't shoot it down, they would just simply chase it and cause the pilot to open the throttles. Although these planes went really fast, over 400 miles, 430 miles an hour or something, we had a navigator that was in here half a dozen years ago. He was 94 years old at that time, and sharp as a tack. I loved talking to him. And although he didn't fly the plane, he was in a Mosquito. And I asked him, I said, well, you know, did you see any action, or, you know, did you get hit, or did you crash, or any of that stuff? And I don't mean to sound morbid, but, you know, I'm interested. And he says, you never knew. He said, the plane, you know, it rode like a bag of hammers. It just bounced all over the sky. The engine's thunder. You got a propeller that's only a matter of 3 or 4 feet away from you, just whizzing around there. You're in a side of a plastic bubble, and the visibility is crap. Everything's blurry, and you just went and did your job. And when you got back, you got out and you thought, oh, that was a pretty good ride. And then you come to the back of the plane, and there's a 2-foot hole in the back where a shell went through. But being wood, the Mosquito could take that punishment. You know, where the other planes, the metal planes, were riveted, and once you lost a panel, you're subject to that airstream that could start tearing the plane apart. Wood reacts different, so they were a decent plane on getting their people back. So, any other questions? Or one more.
Did the German ace Galan ever say, we're in trouble?
I don't know that one, no. Yeah. But they would chase the Mosquito, and knowing that if they get him to burn the fuel, they wouldn't make it back home. That navigator told me from the time he left to the time he got back, it was all about fuel management. I think just over 300 miles an hour is optimum cruising speed for that plane. They move pretty good, but once you got over that speed, you were just blowing fuel out the pipe. Okay, anyways, I'll be down there. You want to come down and see the plane? I'll take the one more question the man had here in the checkered shirt. No, both engines turn the same way, which is unusual, but that's what Merlins do. They all turn the same way.
Okay. Thank you, sir. And don't forget the donation box when you wander over to have a look at the plane. On behalf of Elder College, I want to thank all of you for being here. And I want to thank the Aviation Museum and the team that's put together the Mosquito and the guys who were crazy enough to go up north. I want to thank all of them for the work they put into this. And Andy, I want to thank you for the tremendous show you put together as well.
Andy,
so
well
thank
done.
you very much, everybody. And don't forget the donation box.
Thank you, Lloyd. On behalf of the museum, I would like to thank all of our panel members. Imagine 28 years ago, a group took that voyage and came back with what is going to be a classic here. So thank you for the panel members, okay? Some other thanks that we have to pass out here. This happened because of our volunteers here. Mary Guthrie, who did the organizing of the whole physical part, the goodies, Don Christopher for setting up the sound system, John Garswood for the work on the drapes back there, and Paula Beach working in the gift shop. Now, one person that I want to make well known is Andy Pumpel. If Andy, you would stand up.
Yeah.
No? He doesn't want to do it? Okay. We started, 6 weeks ago, just to meet together, and Andy is the glue that brought this all together. He's put in hours and hours of work, so thank you, Andy, okay? Now, I've been asked to do this. How many people here today have never been here before? Okay? So this is one of our problems here in Windsor, is getting the word out there. So when you leave here and you talk to somebody, spread the word, okay? Now, the last thing that I want to say here is recently we had the 30th anniversary of the museum, and one of our former members left us with some very neat words, and I'm going to call him the unknown panelist, okay? So these are his words, and I think they're very fitting, and hopefully I can do it justice. The Canadian Aviation Museum has come a long way from its humble beginnings. Our building was a gift from a kind donor. Our growth, at times challenging, is an example of good people, our volunteers, working to make this amazing place a better place. Everything our members have ever wanted has come to fruition. From our yellow birds, the Mosquito Bomber Group, our Bad Penny City of Windsor Lancaster, the restoration of the historically significant building, number 7 Elementary Flying School. The foundation of our success is our desire to remember the men and women who built, flew, and died in the aircraft we treasure here in this wonderful place. How fitting that is on D-Day. On behalf of all the Canadian Aviation Museum members, thank you very much for being with us today.